Hello, welcome to this video. Last video, we found out this formula, that the choose function, which is defined by Pascal's triangle, is also the binomial coefficient after expanding out x plus y to the n into the sum. Today, we will use this formula to find a formula for the choose function and choose k. So first things first, I will put in here y is equal to 1 because it will make some calculations later on a bit easier. So we will have x plus 1 to the n is equal to, now putting in here y is equal to 1, we'll have 1 to something power n minus k. So we know that that always is equal to 1. That's multiplied by something, so the entire y term just disappears. And we have left the sum, bring it to the side, the sum as k goes from 0 to n of n choose k times x to the k. Now, let's just put in here some values of n and let's just see what it looks like. So, for n is equal to 2, we have x plus 1 squared. Then n equals 3, we have x plus 1 cubed, x plus 1 to the 4th, and so on. This reminded me of a function. This is the function f of x is equal to x plus 1 to the n. And if it's a function, let's take the derivative and see what happens. So, if we take the derivative, we'll have d over dx on both sides. And what we'll get is, here by the chain rule, n hops to the front, and we erase 1 from it. So we'll have n times x plus 1 to the n minus 1, and then times the derivative of the inside. That's just 1. Derivative of x plus 1 is 1. So we'll get n times x plus 1 to the n minus 1 is equal to, now the derivative of this, you have all the sum choose function mess, and then we have just some x to the k. And again, by the chain rule, the k will hop on over inside the sum, and the k will turn to k minus 1. So I'll have the sum as k goes from 0 to n of k times n choose k times x to the k minus 1. Now, before we play with this a lot, I just want to quickly see that the 0th term in this sum is just 0 because we have 0 times something times something. So this will turn into a 0. So the 0th term is 0, meaning that we can erase the 0 and instead start at 1. That won't affect the sum. Now, notice that by this formula, we can turn this into a sum. This is going to be this. I'll put in the sum already and put the n inside. So the sum as k goes from 0 to n minus 1 of n times n minus 1 choose k times x to the k. Now, here is what I will do. I will replace here k with k plus 1. So this k will turn to k plus 1, this k will turn to k plus 1, k minus 1 will turn to k. Instead of going from 1 to n, it's going to be from 0 to n minus 1. So we're going to have the sum as k goes from 0 to n minus 1 of k plus 1 times n choose k plus 1 times x to the k. Now, let's see. We have one sum starting at 0 ending in n minus 1 of something times x to the k. We have another sum starting at the same 0 to the same n minus 1 to something times x to the k. What does that mean? That means that if, say, expand the sum, each one of those terms, the 0th term, the first and second term on both sides will all be equal, and so will the kth term. So what we will get is that this is equal to this. So we have n times n minus 1 choose k is equal to k plus 1 times n choose k plus 1. Now we got to this property. Let's change it a little so it will look nicer. First of all, we will replace the k with k minus 1. It works for any k, so it works for any k minus 1. It will be nice, so this k will turn to k minus 1, and like it's symmetry to the n minus 1 here. K plus 1 and k plus 1 will turn to k. So that's nice. So we'll get the property n times n minus 1 choose k minus 1 is equal to k times n choose k. And then dividing by k on both sides, we get that n choose k is equal to n over k times n minus 1 choose k minus 1. Now what can we do from here? Well, by this property, we know that n minus 1 choose k minus 1 is n minus 1 over k minus 1 times n minus 2 choose k minus 2. So, like this, we'll get that n choose k is n times n minus 1 over k times k minus 1 times n minus 2 choose k minus 2. But why stop here? We can use the same formula on n minus 2 choose k minus 2 to get n times n minus 1 times n minus 2 over k times k minus 1 times k minus 2 times, we'll have n minus 3 choose k minus 3. Then let's go all out, and then we'll have equals, a bunch of equals until we get to where we're subtracting k in the choose. So we'll have n minus k choose 0. And by the way, we'll first subtract k and not n, because if you remember by definition of n choose k, I didn't say that last video, but it's easy to see that n is always greater than or equal to k. So it will reach k first, always. So n minus k choose 0, because k minus k is equal to 0, times c will have n times n minus 1 times n minus 2, on and on and on, until n minus k plus 1 over, on the bottom we have k times k minus 1 times k minus 2, on and on and on, till we have times 2 times 1. But now, n minus k choose 0. We know that 0, because anything choose 0, sorry, is 1. Anything, because anything choose 0 is 1. So, we get that this disappears. Now let's stop for a moment, because this looks a bit ugly. First of all, k times k minus 1 times k minus 2, on until 1, it's the definition of the factorial. So we'll have on the bottom a k factorial. Now on the top, it's not that hard to see why. I'll leave it to you as a little bit of homework to see why. But in the top, we have n factorial over n minus k factorial. Again, not that hard to see why. If you expand it, a lot cancels out and you get to this. And now, we will take the n minus k factorial and bring it to the bottom. And we'll have n factorial left at the top. And so what do we get? Well, we get n factorial over k factorial times n minus k factorial. And that's it. A simple, nice formula for the n choose k function. Now, let me erase the board and just write the formula and end the video. So, now, if you enjoyed this video about the choose function, please subscribe to my channel. I'll be uploading more content like this. Finally, that is it.